studied how to find the slope of a line when 2 points on the line are given. When angle made by the line is an acute angle. Okay. So next we will study how to find the slope of a straight line when 2 points on the line are given when angle made by the straight line is an obtuse angle. Okay. That is when theta is an acute angle and x1, y1, x2, y2 are the 2 points on the straight line, then slope of the straight line is x2, y2 minus y1 divided by x2 minus x1. Okay, now let us see what is the slope in this case. That means if theta is an obtuse angle, so and 2 points, when 2 points on the line are given, what is the slope? See, let us take 2 points x1, y1 and x2, y2. Okay, let us take 2 points P of x1, y1 and it is the point Q of x2, y2. Okay, now let us join this and here let us draw a straight line that is perpendicular line to x-axis. Okay, now here since it is theta, we know that these angles are supplementary. Okay, that is this total angle is 180 degree. If it is theta, it is nothing but 180 minus theta. Okay. If it is 180 minus theta, see no doubt it is 180 minus theta. Okay. Therefore, see let us take this point as M. Okay. Now here, see MPQ. Angle MPQ is equal to 180 minus theta. Isn't it? See why? Because it is 180 minus theta and it is 90 degree as same as the same theory as just before. Okay, we did just before. See 180 minus theta. If it is 180 minus theta and it is 90 degree and we know that the total angle is the sum of interior angles of a triangle is 180 degree. Therefore it is 90. Then so it is nothing but 180 minus 90 plus 180 minus theta. So after calculation you will get the same thing 180 minus theta. It is also 90 degree because this line is perpendicular to x-axis. So it is 180 minus theta, that is MPQ. Angle MPQ is 180 minus theta. So let us take theta left side and angle MPQ right side. So we can write it as 180 minus angle MPQ. Okay. Next. See, what is the slope? Slope is denoted by M, that is tan theta. Okay. Slope is equal to tan theta if theta is the inclination of the line. So M is equal to tan theta. So we can rewrite it as tan theta is nothing but 180 minus angle MPQ. 180 minus angle MPQ. See, and one more thing, see, we have already learned in trigonometric identities, tan 180 minus theta is minus tan theta. Tan 180 minus theta is equal to minus tan theta. This one we have already learned in trigonometric chapter. Okay. So here tan 180 minus angle MPQ is minus tan MPQ. Angle MPQ. Okay. So here we have got the angle minus tan angle MPQ. Angle MPQ is this one. So what is angle MPQ? That is, see here also let us apply a trigonometric ratio, that is tan theta is in a right angle triangle, tan theta is opposite side divided by adjacent side. Here opposite side is MQ, so minus MQ divided by adjacent side is MP. Okay, since it is a right angle triangle, we can apply trigonometric identity, trigonometric ratio, that is tan theta is equal to opposite side divided by adjacent side. Here tan theta, that is tan MPQ, this angle, okay, here angle is about this one. So tan MPQ is opposite side, that is MQ divided by adjacent side, that is MP. Okay. Now let us find this distance. So what is MQ? See, Since it is the point x2, y2, it is the point x2, y2, we know that, see, it is x2. Okay, it is x2. It is x2. Okay, this point is x2. See, next y2. See, it is about, it is parallel to y-axis. So, we have to find the value of y coordinate, right? So, let us take y2. See, y2 means, it is the point x2, y2 means this length is y2. Okay, from here to here, it is y2. And it is the point x1, y1. So, it is the point x1, y1 means, see, from here to here, it is y1. Okay, it is y1, that is, it is y1. Okay, it is y2 and it is y1, so it is nothing but y2 minus y1. Okay, so here we can say MQ is y2 minus y1. Okay, next, see, we have to find this one, right? Adjacent side, that is MP. See how to find. Since it is the point x2, y2, okay, it is the point x2, y2, x2 means, see, this length, this distance is x2, this distance is x2, this distance is x2. And it is the point x1, y1, okay, this distance is x1, okay, this distance is x1. See, here, if it is here, it is x1, okay. So, this point is nothing but, see which one, yes, we have to find this one, right? Okay, it is the point x1. Okay, why? Because this point is x1 means this distance is x1. Okay, this distance is x1. Okay, if it is x1 and if it is the point x2, so this one is x2. So this is nothing but x1 minus x2. Okay, x1 minus x2. Understood? See here, it is the point x2, y2. Okay, so just consider y coordinate. If we have to find this a line distance parallel to y axis means we have to consider y coordinate value. Okay, here it is y2. Y2 means from here to here the distance is y2. Okay, and it is the point x1, y1. Okay, y1. So this point is, this distance is y1. This distance is y1. So it is nothing but total y2 minus y1. Okay, so it is y2 minus y1. Next, MP, that is about parallel to x-axis. So, just we consider x coordinate value. Okay, so here it is x1. Okay, since it is the point x1, y1, so x coordinate is x1. So, this distance is x1. So, and here it is the point x2, y2. So, this distance is x2. It is x1, it is x2. Okay, so total minus this one, we will get this one, right? So total is x1 minus x2 is equal to this length. That is x1 minus x2. So MP is x1 minus x2. So let us multiply this minus here. So we will get y2 minus y1 divided by x2 minus x1. So in this case also we got the same formula. That is y2 minus y1 divided by x2 minus x1. So if theta is an acute angle, the slope of the straight line y2 minus y1 divided by x2 minus x1, and if theta is an obtuse angle, the slope is same thing, that is y2 minus y1 divided by x2 minus x1. If x1 y1 and x2 y2 are the points on the straight line. Okay, and one more thing, see here, if you take any 2 points, okay, any 2 points on the straight line, you will get the same slope. Okay, the slope will not change. Okay, if you consider any 2 points, see, you will get the same slope. Slope is constant. Okay, so here it will not change. So here, if you 2 points are given and theta is whatever, see, obtuse angle or acute angle. If x1 y1 and x2 y2 are the 2 points on the straight line, the slope of the line is y2 minus y1 divided by x2 minus x1. Remember, next year also you have to study slope of the straight line when 2 points on the line, 2 points x1, y1 and x2, y2 are on the line are given. You have to, the slope is y2 minus y1 divided by x2 minus x1. Now let us go through some questions. Find the slope of the lines passing through the points 3, minus 2 and minus 1, 4. Here, see, 2 points on the line are given. We have to find the slope of the lines. So here we know that what is the slope equation of the slope of a line. If x1 y1 and x2 y2 are the points of the points on the line, then slope of the line is y2 minus y1 divided by x2 minus x1. So here let us take it is x1 y1 and x2 y2. Then slope is nothing but slope m is equal to y2 minus y1 divided by x2 minus x1. Okay, so that is y2 is 4 minus y1 is minus 2, so 4 plus 2. Okay, 4 minus minus 2, that is 4 plus 2 divided by minus 1 minus 3, minus 1 minus 3. So 6 by minus 4, that is minus 3 by 2. So we have got slope of these lines passing through the points 3, minus 2 and minus 1, 4 is minus 3 by 2. See, in the same way, okay, same method, second one, m is equal to, here also let us take it is x1 y1, x2 y2, x1 y1, x2 y2. Okay, these 2 points are on the straight line. We have to find the slope of this straight line, and formula is y2 minus y1 divided by x2 minus x1. y2 is 4 minus minus 2, that is 4 plus 2. Okay, 4 plus 2 divided by 3 minus 3. 3 minus 3, that is 6 divided by 0, it is infinity. Okay, it is not defined. So here the slope is approaching to infinity. And next is, see, next question, making inclination of 60 degree with the positive direction of x-axis. See here the angle made by the straight line is given. Okay, the angle, the straight line making the inclination, that is straight line making the angle 60 degree, inclination 60 degree with the positive direction of x-axis. We know that if theta is the inclination of the line, then tan theta is the slope of that straight line. Okay, so here tan theta, m is equal to tan theta, that is tan 60 degree. Sin 60 divided by cos 60. What is sin 60? Root 3 by 2. Cos 60 is 1 by 2. 2 cancelled. So root 3 is the slope of this straight lines making inclination of 60 degree. Next we will study slopes of 2 parallel lines. If 2 lines are parallel, what are their slopes? Okay, let us see 2 lines L1 and L2 in xy plane. So here the angle made by the first line L1 is alpha. The inclination of the line L1 is alpha. Let inclination of L2 be beta. Okay, since these 2 lines are parallel, these angles must be same. Okay, so alpha is equal to beta. The angle alpha is equal to beta. Why? These 2 lines are parallel, so their angle made by these 2 lines are same. Okay, so alpha is equal to beta and tan alpha is equal to tan beta. Okay, if m1 is the slope of the line L1, okay, and m2 be the slope of the line L2, then m1 is equal to tan alpha and m2 is equal to tan beta. Okay, if m1 is the slope of the line L1 and m2 is the slope of the line L2, then m1 is equal to tan alpha. m1 is equal to tan alpha, that is the slope of the line L1, and m2 is the slope of the line L2. Okay, therefore m2 is equal to tan beta. Since tan alpha is equal to tan beta, m1 is equal to m2. Okay, so here we can write tan alpha is equal to tan beta, implies m1 is equal to m2. So we can say that if 2 lines are parallel, then their slopes are equal. Okay, or we can say if two lines L1 and L2 are parallel if and only if their slopes are equal. Now we will study slopes of two perpendicular lines. Just before we have studied what is the slopes of two parallel lines. If two lines L1 and L2 are parallel, if and only if their slopes are equal. Okay, so here let us see what is the relationship between the slopes of their lines which are perpendicular. Okay, so here let us take let L1, this line be the L1 and this line be the L2. And let alpha be the angle made by the line L1 and beta be the angle made by the line L2. Okay, and let M1 be the, M1 is the slope of the line L1 and M2 is the slope of the line L2. Okay, here see it is alpha. Since these two lines are perpendicular, it is 90 degree. Okay, because these two lines are perpendicular, this no doubt this angle is 90 degree. Since the sum of interior angles of a triangle is 180 degree, this angle is nothing but 180 minus 90 plus alpha. This angle is 180 minus 90 plus alpha. 180 minus 90, 90 minus alpha. Okay, so this angle is 90 minus alpha. Why? Because the sum of interior angles of a triangle is 180 degree. Okay, therefore it is 180 minus 90 plus alpha, that is 90 minus alpha. And see here these two angles are supplementary, that is sum is 180 degree. So here this beta is nothing but 180 minus 90 minus alpha. Okay, it is 90 minus alpha. So this beta is nothing but 180 minus 90 minus alpha. 180 minus 90, 90 minus minus plus alpha. So beta is equal to 90 plus alpha. Okay, now we will write the slope M2. Okay, see M2 is nothing but slope of the line L2. Okay, so M2 is equal to, and beta is the angle made by the line L2. Therefore, tan beta is the slope of the line L2. Okay, because beta is the inclination of this line L2. Okay, therefore we can write M2 is equal to, M2 is the slope of the line L2 and beta is the angle made by the line L2. Therefore, M2 is equal to tan beta by the definition of the slope. Okay, and here tan beta. So what is beta? Beta is nothing but 90 plus alpha. Okay, tan 90 plus alpha. In trigonometry chapter, we have already studied what is tan 90 plus theta. Tan 90 plus theta is minus cot theta. Okay, so here minus cot alpha. We can write it as minus 1 by tan alpha. See what is tan alpha? See, alpha is the angle made by the line L1. Okay, alpha is the angle made by the line L1. That is, alpha is the inclination of the line L1. Therefore, tan alpha is the slope of the line L1. Okay, that is tan alpha is the slope of the line L1, that is M1. Okay, so here we can write minus 1 by tan alpha is nothing but M1. Okay, so here we have got M2 is equal to minus 1 by M1. So M1, take M1 here, M1 into M2 is equal to minus 1. Very important. If two lines are perpendicular, then and M1 and M2 are the slopes of the lines, then M1 into M2 is equal to minus 1. Okay, if two lines are perpendicular and M1 and M2 are the two lines, slopes of the lines, then M1 into M2 is equal to minus 1.